Dialogue, yes. What about noticing them? What about noticing signals? Do you hope? So one thing we've been talking about is getting signatures, biosignatures, techno-signatures about other planets. Maybe if we're extremely lucky in our lifetime to be able to meet life forms, get evidence of living or dead life forms on Mars or the moons of Jupiter and Saturn. What about getting signals from outer space, interstellar signals? What would those signals potentially look like?
That's a hard question to answer because we are essentially engaging in xenopsychology to some degree. What are the activities of another civilization? A lot of that is
What does the word xenopsychology, I apologize to interrupt, mean?
Well, maybe I'm just fabricating that word really, but
Sounds like
they're trying to guess at the machinations and motivations of another intelligent being that was completely evolutionary divorced from us.
So it's like you said, exomoons, it's exopsychology, extrasolar psychology.
Yeah. Alien psychology is another way of maybe making it more grounded. But we can't really guess at their motivations too well, but we can look at the sorts of behaviors we engage in and at least look for them. We're always guilty that when we look for biosignatures, we're really looking for, and even when we look for planets, we're looking for templates of Earth. When we look for biosignatures, we're looking for templates of Earth-based life. When we look for techno-signatures, we tend to be looking for templates of our own behaviors or extrapolations of our behaviors. So there's a very long list of techno-signatures that people have suggested we could look for. The earliest ones were, of course, radio beacons. That was sort of Project Ozma that Frank Drake was involved in, trying to look for radio signatures, which could either be just like blurting out high power radio signals saying, hey, we're here, or could even have encoded within them galactic encyclopedias for us to unlock, which has always been the allure of the radio technique. But there could also be unintentional signatures. For example, you can have something like the satellite system that we've produced around the Earth, the artificial satellite system, Starlink type systems we mentioned. You could detect the glint of light across those satellites as they orbit around the planet. You could detect a geostationary satellite belt, which would block out some light as the planet transited across the star. You could detect solar panels potentially spectrally on the surface of the planet. Heat island effects. New York is hotter than New York State by a couple of degrees because of the heat island effect of the city. And so you could thermally map different planets and detect these. So there's a large array of things that we do that we can go out and hypothesize we could look for. And then on the furthest end of the scale, you have things which go far beyond our capabilities, such as warp drive signatures, which have been proposed. You get these bright flashes of light, or even gravitational wave detections from LIGO could be detected. You could have Dyson spheres, the idea of covering basically a star is completely covered by some kind of structure which collects all the light from the star to power the civilization. And that would be pretty easily detectable to some degree because you're transferring all of the visible light. Thermodynamically, it has to be re-emitted, so it would come out as infrared light. So you'd have an incredibly bright infrared star, yet one that was visibly not present at all. And so there would be a pretty intriguing signature to look for.
Well, is there efforts to look for something like that for Dyson spheres out there with the strong infrared signal?
There has been, there has been, and there's been. I think in the literature there was one with the IRAS satellite, which is an infrared satellite. They targeted, I think, of order of 100,000 stars, nearby stars, and found no convincing examples of what looked like a Dyson sphere star. And then Jason Wright and his team extended this, I think, using WISE, which is another infrared satellite, to look around galaxies. So could an entire galaxy have been converted into Dyson spheres, or a significant fraction of the galaxy, which is basically the Kardashev Type 3, right? This is when you've basically mastered the entire galactic pool of resources. And again, out of 100,000 nearby galaxies, there appears to be no compelling examples of what looks like a Dyson galaxy, if you want to call it that. So that by no means proves that they don't exist or don't happen, but it seems like it's an unusual behavior for a civilization to get to that stage of development and start harvesting the entire stellar output.
Unusual, yes. I mean, LIGO is super interesting with gravitational waves. If that kind of experiment could start seeing some weirdness, some weird signals, some that compare to the power of cosmic phenomena.
Yeah. Yeah. I mean, it's a whole new window to the universe, not just in terms of astrophysics, but potentially for techno-signatures as well. I have to say, with the warp drives, I am skeptical that warp drives are possible, because you have kind of fundamental problem relativity. You can either really have relativity, faster than light travel, or causality. You can only choose two of those three things. You really can't have all three in a coherent universe. If you have all three, you basically end up with the possibility of these kind of temporal paradoxes and time loops and grandfather paradoxes.
Well, can't there be pockets of causality, something like that? Like where there's like pockets of consistent causality.
You could design it in that way. You could be, if you had a warp drive or a time machine, essentially, you could be, you could be very conscious and careful of the way you use it, so as to not to cause paradoxes or just do it in a local area or something. But the real fundamental problem is you always have the ability to do it. And so in a vast cosmic universe, if time machines are all over the place, that there's too much risk of someone doing it, right? Of somebody having the option of essentially breaking the universe with this. So there's a fundamental problem. Hawking has this chronology protection conjecture where he said that essentially that this just can't be allowed, because it breaks all our laws of physics if time travel is possible.
Current laws of physics, yes.
Correct. Yeah. And so we'd need to rip up relativity. I mean, that's the point, is the current laws of physics. So you'd have to rip up our current law of relativity to make sense of how FTL could live in that universe, because you can't have relativity, FTL, and causality sit nicely and play nicely together.
But we currently don't have quantum mechanics and relativity playing nice together anyway, so it's not
Correct.
like everything is all a nice little fabric.
It's certainly not the full picture. There must be more to go.
Yeah.
But
so it's already ripped up, so might as well rip it up a little more. And then, and in the process, actually try to connect the two things, because maybe in the unification of the standard model and general relativity, maybe there lies some kind of new wisdom about about warp drives. So, by the way, warp drives is somehow messing with the fabric of the universe to be able to travel faster than the speed of light.
Yeah, you're basically bending space time. You could also do it with a wormhole or some of the hypothetical FTL systems. Doesn't have to necessarily be the Alcubierre drive, the warp drive. It could be any faster than light system. As long as it travels superluminally, it will violate causality and relativity.
And presumably that will be observable with LIGO.
Potentially. Depends on, I think, the properties of whatever the spacecraft is. I mean, one problem with warp drives is there's all sorts of problems with warp drives, but when
the start of that sentence, one problem with warp drives.
There's just this one minor problem that we have to get around. But when it arrives at its destination, it basically collects this vast, basically has like an event horizon almost at the front of it, and so it collects all this radiation at the front as it goes, and when it arrives, all that radiation gets dumped on its destination and would basically completely exterminate the planet it arrives at. That radiation is also incident within the shell itself. There's Hawking radiation occurring within the shell, which is pretty dangerous. And then it raises all sorts of exacerbations of the Fermi paradox, of course, as well. So you might be able to explain why we don't see a galactic empire. I mean, even here it's hard. You might be able to explain why we don't see a galactic empire if everybody's limited to Voyager 2 rocket speeds of like 20 kilometers per second or something. But it's a lot harder to explain why we don't see the stars populated by galactic empires when warp drive is eminently possible, because it makes expansion so much more trivial that it makes our life harder. There's some wonderful simulation work being done out of Rochester where they actually simulate all the stars in the galaxy, or a fraction of them, and they spawn a civilization on one of them, and they let it spread out at sublight speeds. And actually the very mixing of the stars themselves, because the stars are not static, they're in orbit of the galactic center, and they have crossing paths with each other. If you just have a range of even like 5 light years, and your speed is of order of a few percent the speed of light is the maximum you can muster, you can populate the entire galaxy within something like 100,000 to about 1 million years or so. So another a fraction of the lifetime of the galaxy itself. And so this raises some fairly serious problems, because if any civilization in the entire history of the galaxy decide to do that, then either we shouldn't be here, or we happen to live in this kind of rare pocket where they chose not to populate to. And so this is sometimes called fact A, Hart's fact A. As the fact A is that a civilization is not here now. An alien civilization is not in present occupation of the Earth, and that's difficult to resolve with the apparent ease at which even a small extrapolation of our own technology could potentially populate a galaxy in far faster than galactic history.
So to me, by the way, yeah, the Fermi Paradox is truly a paradox for me. But I suspect that if aliens visit Earth, I suspect if they do, if they are everywhere, I think they're already here and we're too dumb to see it. But leaving that aside, I think we should be able to, in that case, have very strong, obvious signals when we look up at the stars, at the emanation of energy required. We would see some weirdness that, like, where these are these kinds of stars and these are these kinds of stars that are being messed with, like leveraging the nuclear fusion of stars to do something useful. Right. Like the fact that we don't really see that, like maybe you can correct me. Wouldn't we be able to, if there is like alien civilizations running galaxies, wouldn't we see weirdnesses from an astronomy perspective with the way the stars are behaving?
Yeah, I mean, it depends on exactly what they're doing, but I mean, the Dyson sphere example is one that we already discussed, where a survey of 100,000 nearby galaxies find that they have all been transformed into Dyson sphere collectors. You could also imagine them doing things like, we read a paper about this recently, of star lifting, where you can extend the life of your star by scooping mass off the star. So you'd be, doing stellar engineering essentially. Space, if you're doing a huge amount of asteroid mining, you would have a spectral signature because you're basically filling the solar system with dust by doing that. There'd be debris from that activity. And so there are some limits on this. Certainly we don't see, bright flashes, which would be, one of these consequences of warp drives, as I said, is as they decelerate, they produce these bright flashes of light. We don't seem to see evidence of those kind of things. We don't see anything obvious around the nearby stars or the stars that we've surveyed in detail beyond that indicate any kind of artificial civilization. The closest maybe we had was Boyajian star that there was a lot of interest in. There was a star that was just very peculiarly dipping in and out its brightness. And it was hypothesized for a time that may indeed be some kind of Dyson-like structure. So maybe a Dyson sphere that's half built. And so as it comes in and out, it's blocking out huge swaths of the star. It was very difficult to explain it really with any kind of planet model at the time. But an easier hypothesis that was proposed was it could just be a large number of comets or dust or something, or maybe a planet that had broken apart, and as its fragments orbit around, it blocks out starlight. And it turned out, with subsequent observations of that star, which especially the amateur astronomy community made a big contribution to as well, that the dips were chromatic, which was a real important clue that probably wasn't a solid structure then that was going around it. It was more likely to be dust. Dust is chromatic. By chromatic, I mean it looks different in different colors. So it blocks out more red light than blue light. If it was a solid structure, it shouldn't do that. It should be opaque, right? A solid metal structure or something. So that was one of the clear indications. And the behavior of and the way the light changed or the dips changed across wavelength was fully consistent with the expectations of what small particulates would do. And so that's very hard. I mean, the real problem with alien hunting, the
technical term.
This is the real
one problem.
Yeah.
The one problem with the warp drive and the one problem with alien hunting. Yes.
But I'd say there's three big problems for me with any search for life, which includes UFOs all the way to fossils on Mars, is that aliens have three unique properties as a hypothesis. One is they have essentially unbounded explanatory capability. So there's almost no phenomena I can show you that you couldn't explain with aliens to some degree. You could say, well, the aliens just have some super high-tech way of creating that illusion. Yeah. The second one would be unbounded avoidance capacity. So I might see a UFO tomorrow, and then the next day, and then the next day, and then predict I should see it on Thursday at the end of the week. But then I don't see it, but I could always get out of that and say, well, that's just because they chose not to come here. They have this, they can always avoid future observations fairly easily. If you survey an exoplanet for biosignatures and you don't see oxygen, you don't see methane, that doesn't mean there's no one living there. They could always be either tricking their atmosphere, engineering it. We actually wrote a paper about that, how you can use lasers to hide your biosignatures as an advanced civilization. Or you could just be living underground or underwater or something where there's no biosignatures. So you can never really disprove there's life on another planet or on another star. It has infinite avoidance. And then finally, the third one is that we have incomplete physical understanding of the universe. So if I see a new phenomena, which Boyajian star was a good example of that, we saw this new phenomena of these strange dips we'd never seen before. It was hypothesized immediately this could be aliens. It's like a god of the gaps, but it turned out to be incomplete physical understanding. And so that happens all the time. In the first pulsar that was discovered, same story. Jocelyn Bell kind of somewhat tongue-in-cheek called it Little Green Man 1 because it looked a lot like the radio signature that was expected from an alien civilization. But of course, it turned out to be a completely new type of star that we had never seen before, which was a neutron star with these two jets coming out the top of it. And so that's a challenge. Those three things are really, really difficult in terms of experimental design for a scientist to work around. Something that can explain anything, can avoid anything, so it's almost unfalsifiable, and could always just be, to some degree, as you said, we have this very limited knowledge of the infinite possibilities of physical law, and we're probably only scratching the surface. Each time, and we've seen it so often in history, we may just be detecting some new phenomena.
Well, that last one, I think I'm a little more okay with making mistakes on.
Yeah,
which is
because it's exciting still.
But it's because no matter, so you might exaggerate the importance of the discovery, but the whole point is to try to find stuff in this world that's weird and try to characterize that weirdness. Sure, you can throw a Little Green Man as a label on it, but eventually it's as mysterious and as beautiful as interesting as Little Green Man. Like we tend to think that there's some kind of threshold. But like, there's all kinds of weird organisms on this earth that operate very differently than humans that are super interesting. The human mind is super interesting. I mean, like, weirdness and complexity is as interesting in any of its forms as what we might think from Hollywood what aliens are. So like that's okay. Looking for weirdness is on Mars.
That's one of the best sales pitches to do techno-signature work, is that, we always have that as our fallback, that look, we're going to look for alien signatures. If we fail, we're going to discover some awesome new physics along the way. And so even any kind of signature that we detect is always going to be interesting. And so that compels us to have not only the question of looking for life in the universe, but it gives us a strong scientific grounding as to why this sort of research should be funded and should be executed, because it always pushes the frontiers of knowledge.
I wonder if we'll be able to discover and be open enough to a broad definition of aliens, where we see some kind of techno-signature, basically like a Turing test, like this thing is intelligent. Like it's processing information in a very interesting way. But you can say that about chemistry. You could say that about physics. Maybe not physics, chemistry. Like interesting, complex chemistry. You could say that this is processing. This is storing information. This is propagating information over time. So I mean, it's a gray area between a living organism that we would call an alien and a thing that's super interesting. It's able to carry some kind of intelligence.
Yeah, information is a really useful way to frame what we're looking for, though, because then you're divorced from making assumptions about even a civilization necessarily or anything like that. So any kind of information-rich signature, indeed, you can take things like the light curve from Boyajian star and ask, what is the minimum number of free parameters or the minimum information content that must be encoded within this light curve? And the hope is that maybe from, a good example would be from a radio signature, you detect something that has 1,000 megabytes of parameters essentially contained within it. That's pretty clearly at that point not the product of a natural process, or at least any natural process that we could possibly imagine with our current understanding of the universe. And so thinking, even if we can't decode, which actually I'm skeptical we'd be able to ever decode it in our lifetimes, it would probably take decades to fully ever figure out what they're trying to tell us. But if there was a message there, we could at least know that there is a high information content and there is complexity, and that this is a attempt at communication and information transfer, and leave it to our subsequent generations to figure out what exactly it is they're trying to say.